In this video, we're going to see how to arrange a bunch of objects where some of the objects want to be kept apart. So let's start with an example. Suppose that 3 adults and 2 children went to see the movie The Lion King as a reward. How many different ways are there to sit in a row so that the 2 children do not sit next to each other? So what that means is there is at least one adult between the 2 children. Okay, so this is hard to do all at once. So what we're going to do is try to break the problem up. So what we're going to do is we begin by arranging the adults. So they're not going in the seats, we're just going to put them in a row. And then we're going to try to fit children in between them, and then they can go and sit down. So once they have their order, they can walk into the sort of row in the movie theater and sit down. Okay, but they're going to order before they go and find the seats. So we arrange the adults. So we have 3 adults, and we want to arrange all of them. Okay, so there's 3 factorial or 6 ways to do that. Now, consider this arrangement. So I have 3 adults. So let's say I have adult 1, adult 2, and adult 3. I want to think, where could I put a child? So I could put a kid here, in between A1 and A2, in between A2 and A3, or at the end. So I have 4 spots to put 2 kids. Okay, so I have 2 kids to fit in here, and I could put them in any of these 4 spots. So what I want to do is select 2 of the 4 spots for the kids to go. Okay, now here, there's options here, so I'm going to say the order doesn't matter, and I'm just going to select the spots. Okay, so that means that there's going to be 4 choose 2 ways just to select spots. So suppose I select spots 1 and 3, for instance. Okay, that could be a selection. I need to know which kid goes in which spot. So what I want to do is arrange the kids into the selected spots. So to do that, there's going to be 2 factorial ways. So I just arrange the 2 kids once I know which spots they're going in. So that means that the total number of ways they can sit down is going to be 3 factorial, so arrange the adults, choose the spots for the kids, and then arrange the kids into those spots. Now, when we choose and then arrange, this is actually saying that the order matters. So we could rewrite this as 3 factorial times 4 permute 2. Okay, so that's saying pick 4 spots where the order you pick them matters. So why would the order matter? Because the first spot you pick could go to kid 1, and the second spot you pick could go to kid 2. So because you're putting different children into the spots, you can think about the order mattering. I prefer to do it in the 3 steps because sometimes we won't want to order the people in. So maybe the objects we're putting in are all the same, or maybe we want a specific order. Maybe kid 1 needs to sit to the left of kid 2 for some reason. Okay, so we might have a specific order to put them in. So I think it's nice to have it as 3 steps so that you know you have to think about, do I want to order them or not? Okay, either way, if you compute this, you should get 72 different seatings. Okay, so let's just summarize what we did here. So when we want to keep things apart, what we want to do is arrange the objects that you don't care about. So the ones that don't need to be a part. Okay, and then what you want to do is select spaces, oops, in between these objects for the objects that need to be kept apart. So this will guarantee that there's at least one of the initial objects in between any two of these new objects. Okay, and then we want to arrange these objects into the selected spaces. Okay, if necessary. So sometimes you might not need this step. So you want to think about if you do. Now, like I said before, okay, these two steps can be combined using a permutation. When the objects are distinct, the separated objects, so objects that are separated, are distinct, and you want all possible orderings. So it's possible to do it in 2 steps. I prefer to think about it as 3 steps because often these type of questions are going to be slightly tweaked, so they're not exactly the same, and you might have to adapt some of these steps. And sometimes it's easier to do when they're in the three-step layout. So let's try another one. Suppose 7 kids enter an arcade and find 7 available video games that are all in a row. Okay, Ethan, Dylan, and Wyatt are among the 7. Okay, so we have E, D, and W plus 4 others. Now these 3 insist on not sitting together. Okay, so they don't want to sit together, so that means we need at least 1 kid in between every 2 of them. So these 3 want to be separated. Okay, they have enough of each other. So we're going to start by arranging the other 4 kids. So to do that, there's 4 factorial ways because we want to arrange all of them. Now, let's say there's kid 1, kid 2, kid 3, kid 4. We want to think about the spaces in between them. So Ethan, Dylan, and Wyatt can go in any of these 5 spaces because they could be at the beginning or the end. So we're going to select 3 of the 5 spaces for Ethan, Dylan, and Wyatt. So that's 5 choose 3 ways. And then we're going to arrange Ethan, Dylan, and Wyatt into these selected spaces. Okay, so that is 3 factorial ways. So our total is going to be 4 factorial times 5 choose 3 times 3 factorial, or you could write it as 4 factorial times 5 permute 3 because we had different people that needed to be separated, and we wanted all possible arrangements. And this is 1,440 ways total. Okay, let's try another one that's slightly different. So consider the letters in the phrase, I like math, ignoring the spaces. So we want to know how many linear arrangements of the above letters have the I's separated. Okay, so we're going to take out the I's, okay, on the side here. What are we left with? Are these letters. So that means there's 7 other letters, okay, other than I's. So we arrange the other letters. So there's going to be 7 factorial ways to do that. Now I'm just going to use this arrangement I have up here to count the spaces in between. So because the I's can go at the beginning and the end, we're going to have 8 spaces in between them. So we select 2 of the 8 spaces for the I's. So that's going to be 8, choose 2. Now this last step, do we need to arrange them? Okay, so I'm going to write that we do. So arrange I's into the 2 spaces. Because the I's are the same, we don't actually have to do this. So there's only one way to arrange them. So once I know which 2 spaces, so maybe they're going to be in space 3 and 4, they both get an I. So there's no multiple ways that I can put the I's in. So that means that the total is going to be 7 factorial times 8, choose 2. So here we could not use a permutation because the 2 things we're inputting are not unique. Okay, so this is 141,120 ways or arrangements. Now, a slight alteration of this, in how many arrangements of these letters are the I's separated by exactly 1 letter? Okay, so in the spots I picked in this example, the I's only had the E between them. So this would be an example, but I could have picked spaces 1 and 8, and then there would have been lots of letters in between them. Okay, so this is slightly different. Okay, we still want to start by arranging the other letters. So there's still going to be 7 factorial ways to do that. Let me just write them out here. So this is 1 arrangement. Now, if I put an I in this space, the next I has to go here. So picking 1 space determines where both of them go. Okay, so I could put an I here before the L. I could put an I before the K, and then it would go, the next I would go after the K. Similarly, I could put I's in all of these spots, but I don't want to count this last spot. So I'm going to write not a spot. So if I pick the spot before the H, it means that the other I is going to go directly after it. Okay, so because basically we're picking, so I'm going to write here, select the spot of the leftmost I. Okay, so I can't put the leftmost I to the far right because then there's no place to put the I that's to the right. So that means in this case, 1, 2, 3, 4, 5, 6. I only have 7 spaces and I want to select 1. So I'm going to have 7 choose 1 ways to do that. And then once I select the space, the other I is determined. Okay, so I put an I on that space and the other I has to go 1 letter away from it to the right. So here, our total is going to be 7 factorial times 7 choose 1, which is 35,280. Okay, so there are some examples of arranging with separation.